Okay, on this we're asked to perform all operations, give all answers in a plus bi form. And so what we're going to do here is we're trying to perform this division. However, when we're dividing with a complex number in the denominator, our goal is to clear out that complex number out of the denominator. So again, that's when we would use our complex conjugate of the denominator and multiply the numerator and the denominator of this fraction by the complex conjugate. So if our complex number here is 3 minus I, the complex conjugate to that is going to be 3 plus I. Remember that the real number stays the same and the sign on the complex or the imaginary part changes. But we need to make sure that we multiply both the numerator and the denominator by that same value, because we can't change the value of this number, and 3 plus I over 3 plus I is just equal to 1. And so that's why we're allowed to do that. We then are going to multiply the numerator together, and we're going to multiply the denominators together. Remember, one big part of why we multiply by the complex conjugate is because we want to get a real number in the denominator. And anytime I multiply a number by its complex conjugate, I get a real number answer. So let's multiply this out. We have -2 times 3. So my numerator here, I'm going to have -6. And then I have -2 times I. So that's going to give me -2i. In my denominator, I'm going to FOIL this out. So I get 3 times 3, which is 9. 3 times I, which is plus 3i. I get -I times 3, so that's -3i. And then I get -I times plus I, so that's -I squared. Again, remember that I squared equals -1, so we can rewrite anything that's in terms of I squared as a -1. So for now, we're going to leave our numerator the same. We have -6 minus 2i. Our denominator, we have 9. We have plus 3i minus 3i. That is just equal to 0, so it goes away. And then I have minus I squared, so that's going to be minus -1. So the I squared is -1, so I still have the minus -1. So from here, we have -6 minus 2i in the numerator, and then our denominator is 9 minus -1, which is equal to 10. What I can now do is I can split this up into the real part and the imaginary part by writing this as -6/10 minus 2i over 10. And then we can simplify each fraction. 6 and 10 are both divisible by 2, so that gives me -3/5. And then minus 2 and 10 are both divisible by 2, so that gives me 1i over 5. Or you could write it as 1/5 I. Okay, it should accept either response. Some people like it like this because it looks more like the A plus BI form, because the coefficient on the I, the multiplier here, is a 1/5. So that is our final solutions for that. So when we are dividing and we have these complex numbers in the denominator, our goal is to try to clear them out. You might see one. Let's do one more. Okay. You might see one that looks like, let's say like 10 over 7i. Okay, so we have an imaginary number in the denominator. This number still has a complex conjugate, because you could think of it as 0 plus 7i. So its complex conjugate would be 0 minus 7i. So the complex conjugate of 7i would just be negative 7i. So what we're going to do here is we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. So in the numerator, we're going to get 10 times negative 7i, so that's negative 70i. And the denominator, we get 7i times negative 7i, so that's going to give me negative 49i squared. We know that I squared equals negative 1, so we can rewrite this as negative 70i over negative 49 times negative 1. So that gives us negative 70i over 49. Okay, now we can divide both the numerator and the denominator, sorry for the pause there, we can divide both the numerator and the denominator by 7. So we end up getting negative 10i over 7. And to write this in our a plus bi form, you can write this as 0 minus 10/7 I. Okay? So if it's being really particular about writing it in the a plus bi form, make sure you include that 0 for that real number part, 0 minus 10/7 I. All right, y'all. I'm hoping this helps you with those last few problems on your 1.3 homework. If you have questions, go ahead and email me and let me know. Thank you.